reaction between acids and bases. Let us see an activity to understand this. Take 2 ml of dilute sodium hydroxide and add 2 drops of phenolphthalein. Since sodium hydroxide is a base, phenolphthalein turns it into pink. Now add few drops of HCl. The solution becomes acidic and the pink color disappears. Now add few drops of sodium hydroxide, the pink color reappears. So in this experiment, we have seen that by adding an acid to the base, we can reduce or completely remove the basic nature of the substance. In the same way, by adding a base to an acid, we can reduce or completely remove the acidic nature of that substance. So this type of reactions are called neutralization reactions. When a base reacts with an acid, it forms salt and water. Base plus acid gives rise to salt plus water. Now let's see the reaction of metal oxides with acids. Take a small amount of copper oxide in a beaker and add dilute HCl slowly by stirring. We have taken copper oxide in a beaker and adding dilute hydrochloric acid. Now the color of the solution slowly changes to bluish green color. The copper oxide reacts with hydrochloric acid and forms copper chloride and water. So when a metal oxide reacts with an acid, it forms salt and water. Reaction of non-metal oxides with base. When a non-metallic oxide like carbon dioxide is passed through a base like calcium hydroxide, it forms a white precipitate called calcium carbonate. So here a non-metallic oxide, that is carbon dioxide, it is passed through a base, that is calcium hydroxide. So when they both react, they forms a salt, that is calcium carbonate. So a base plus a non-metallic oxide gives rise to salt and water. Now let us see the common things in both acids and bases. To know the common thing in both acids and bases, we need to perform an experiment. Take some dilute HCl in a beaker and fix 2 electrodes. Now connect these electrodes to 2 wires. To one of the wire, connect a bulb. Now connect the free ends of these wires to a power source and let the current flow. Now the current flows through the solution and the bulb glows. Now replace the contents in the beaker with glucose solution. Earlier we have taken HCl, so in place of that we are taking glucose. Now the bulb does not glow. Again replace the glucose with alcohol. Even with alcohol, the bulb does not glow. Now again replace this alcohol with sodium hydroxide. Now the bulb glows. In this experiment, the bulb glows with HCl and sodium hydroxide and it does not glow with glucose and alcohol. This shows that acids and bases conduct electricity. Do you know why? Acids and bases, when dissolved in water, they produce cations and anions. Cations are the positive ions and anions are the negative ions. When HCl is dissolved in water, it produces cations as H plus ions and anions as Cl minus ions. Anyway, the hydrogen ions cannot exist alone, so they exist in the form of hydronium ions. In the same way, if we dissolve sodium hydroxide in water, it also forms cations and anions. Sodium hydroxide forms Na positive cations and OH minus anions. So this is the common thing in both acids and bases. That is, they both dissolve in water and form anions and cations and they conduct electricity. Now let us see dilute